You want to settle down? Oh, okay, that's good.
It's rolling.
It's rolling, okay, all right. Take a seat, everybody. I forget your name, Letitia and?
Kira, it's Leticia. Leticia.
Leticia.
Yeah.
Okay, and then you are?
Kira.
How do you spell?
K-I-R-A.
K-I-R-A, okay.
It's actually Gurkirat, but then like I shorten it. to
You shorten
Kira.
it, okay? Yeah, okay. All right then, so get settled down, please. Oh, should I put this on or what?
Yeah, you should, because that mic right there, you want to speak into that mic.
So I have to, what do? I just clip it on?
Yes.
Just clip it on.
And you can put that on your pocket if you want.
Oh, I see. Can you erase up to this point? Because I'm asking all, because see, I had to put this online.
Yeah, that's fine.
But like she's also recording it for people who are. You can have
Just hook that to your pocket. Or that.
Can you erase up to this point?
Yeah.
Okay.
No, it's probably in the thingy. I don't have it. Yeah, neither do I.
Okay, ready then? Do you guys have, oh, I forgot to get the notes.
It's okay.
I'll just follow along.
Follow on?
Yeah.
Yeah, I will. Can you real quick get it then?
We can just follow along.
That's fine.
Okay. All right. Just have some pages then. I may have some notes written. Come on in, Rajiv. Do you have your notes?
Printouts?
Yeah.
No.
Okay. Take a seat then.
Is this a review? Or are we learning something?
We are learning something new. Yes. This is. I have few slides from last time. Okay. Okay. So I'll get started then. Okay. All right. Now remember we did in the previous lecture. Not exactly the previous lecture. I think the lecture before that. Random variables. Okay. I'm just doing couple of slides from previously just to review. Okay. Now random variables, there were two of them, two types. Remember, discrete and continuous. Are you guys okay with that? The difference between discrete and continuous. Discrete means it's like the variable values it can take are countable. It's actually for this class purposes, it just count data, number of something like number of errors or number of successes and things like that. As opposed to continuous, it would be like something like maybe birth weight. Birth weight can range from like maybe 6 pounds to 10 pounds, any value between 6 to 10 pounds. Okay, and then it can take any value, like the values that it can take are unbroken, right? So it's like, since you guys have had calculus, it's like if you think of it as the function is continuous. The weight function is continuous. Okay, all right then. So this is from previous. Then let me go to the next one. Now just to refresh your memory, we talked about probability mass function for discrete random variables. That is like when you talk about a discrete random variable, the values x takes are it's like countable. In other words, I sort of say in an informal way, you can label the values. This is like the first possible value. This is a second value. So now you can also calculate the probabilities for each one of them. Okay. Now that is called the probability mass function. We did this last time. Okay. So PMF. So now PMF should add to what? If I add all these numbers, it should add to 1. Okay. So that you guys know. All right. So then let's go to the next one. Yeah. Okay. Now, so this is the beginning of chapter 6. Okay. Now in chapter 6, we are doing the binomial random variable, a specific discrete random variable. Okay. Let me write that on the since I did not give you a specific discrete random variable. Okay. So it's an example. It's an example of a discrete random variable. Okay. So now let's see how that works. All right. Let's go to the next slide. Okay. So now what is a binomial random variable? It is a discrete random variable, as we did in lesson 5. Now in this chapter we will be covering stuff, okay, like calculating binomial probabilities, then calculating cumulative probabilities. Do you guys remember what cumulative probabilities were? Is less than or equal to, remember? So binomial probability, this is like, I can say PMF, right? PMF. This is like CDF. Oops. CDF. So let me sort of put this in red. Yeah, this will be useful. Now, so cumulative probability means less than or equal. Let me write that down. This is exactly equal. This is less than or equal to. Right? Probability of x less than or equal to 3, for example. So we will be learning how to calculate this, okay, and then also we will learn a formula to find the expected value and the variance of a binomial random variable. Remember the symbols for expected value? Mu. Okay, and variance was sigma squared. Remember? Okay, so just just to refresh your memory. And then using binomial, if we have time, we will do some problems. Okay, if not, we will do problems next time. Okay, all right. Let's go to slide 6. All right. Now, binomial is a family of discrete random variables. See, what is meant by a family means you have a whole lot of them, and I will explain to you why it is a family. Okay. Now, what is a binomial random variable? It is number of successors. Okay, that you get when you repeat a process of n trials where each trial has only 2 possible outcomes. Think in terms of tossing a coin. That's the easiest. When you toss the coin 10 times, okay, for each toss is like a trial. Each toss is a trial. Okay, and then what are the possibilities for each toss?
Either heads or tails.
Exactly. So only 2 possible outcomes. Now that is the basic property of a binomial random variable. Each trial has only 2 possible outcomes. Okay, success or failure. So you will label it as success or failure. Okay, and then if you count the number of successors, that will be a binomial random variable. So I said in here x equal to number of heads if you were to toss a coin 10 times. Okay. Because each toss has only 2 possible outcomes, heads or tails. Okay. Now, binomial random variable has 2 parameters. Now, 2 parameters means like specific values. Okay, they are n and p. Now, see, I put in here n equals 10. I can take even 20, 25, whatever, right? I can vary n. And at the same time, p is the probability of success. Now, that could vary from one situation to the other, right? Now, when you toss a coin, of course, what is p? Probability of heads?
1 over 2.
1 over 2, 0.5, 50%, correct?
Right.
Now, if you were to do a survey to find the number of smokers, like, it depends, in fact, from one community to the other, or one age group to the other. So p could vary. Okay, so p can be 0.5, 0.4, 0.3. There's a 30% chance that the people in this community will smoke. Then there will be a 20% chance that people in another community will smoke. So so p can vary. So in that sense, both n and p can vary, and they are parameters. Okay, so now because these 2 varies, that is why binomial is a family. Depending on the different n and p values, you will get different members of the family, right? So I can make a note in here, okay, different values of n and p, okay, will be members of the binomial family. Okay, That's what is meant by a family in here. Okay. Now also look, what are the possible values for x? Now see, we need to convince ourselves that the binomial random variable is discrete. Okay, what are the possible values for x? Think in terms of number of heads. If you are to toss the coin,
10 toss, right?
10 tosses. So what are the possibilities? What's the smallest possibility for x? Number of heads? 0. What's the next smallest? 1. So it can go up to 10. So that's why I say here x is an integer. Oops, x is an integer between 0 and n. Are you guys okay? And see, there are gaps, right? What are the possible values? It can be 0, 1, 2. So it's discrete. It's not continuous. Right, Kira? You okay? Okay. All right, let's go to slide 7. Okay, so binomial example. Now in here they have, okay, they are telling to, okay, consider a random number of successful treatments when treating 4 patients. So you are treating 4 patients and you look to see whether the treatment was successful or not. Okay, so that this is also like a, how many trials are there?
How many successful cases are there?
How many cases? Cases are like trials. So there are 4, right? 4 patients. So n equals 4 here. Okay, and they know that, at least they sort of have an idea that the success rate for this treatment is 75%. So p equals what? P equals 0.75. Success rate is 0.75, right? And then x is the number of successes. That can vary from 0 to 4. So if you are to look at 4 patients who were given the treatment, there can be no patient who got well. There can be exactly 1, 2, 3, or all of them. Correct? So it's a discrete random variables taking values 0, 1, 2, 3, 4. All right. So this is very similar to the coin tossing experiment. The only difference is what? The p. P is different, isn't it? P is 0.75. P is not exactly half of.
And that's the probability of patient who got solved well or who got well.
Yes, probability that any patient can get well. So they can say there's like a 75% chance that
So it will be 3 over 4, right?
3 over 4 if you were to do the experiment over and over. I mean, if you are to do it over, if you are to give the treatment to million patients, perhaps, you know, 75% of them will get sick, will get well.
So it's like, how do we calculate that value, or is it like it would be always given? Like P
Yeah, it
equals
is based
0.75?
on like typically like clinical trials or something. Typically they will do a pilot survey.
Okay.
So, or they have something called, it is a pilot survey. So they may be giving it to, I don't know, 100 people or whatever.
And so but from the value of P, you can say, okay, 75% of the patient got well
Exactly.
among whomever they've treated. or
Yes. Among
among the
those
other patients.
treatment was given to. Yes.
I see.
So that is based on a pilot survey. And then of course, then you will have to, of course, you know, there's like a lot of rigorous work going on, like, you know, when you introduce a treatment or a drug, you know, you will not finish up just with one trial, you know. So then you will try it over so many others, then you will expand your trials, clinical trials, okay. So, but typically you get that value 0.75. It is like a rough value. It is an estimate. Okay. All right then. So now, so x equals number of successors. Okay. Now that is binomial because each trial has only 2 possible outcomes, right? Either get well or not. Okay. And then the n equals 4, p equals 0.75. All right. Now here's notation. Now see, sometimes to make things easy, people use notation. You guys have done calculus and stuff, right? Now B stands for binomial. So if you say for like here, now for this example, I can say this particular x, which is number of successors, you know, that means number of patients who got well. Now that is binomial with 4 because we are, you know, we have tried only 4 patients, and p equals 0.75. So the first value is n, second value is p, okay? Because these are the 2 parameter values which determines that binomial random variable, okay? So this is notation. All right. Next slide. Okay, here calculating binomial probabilities. Remember that was one of the objectives. Okay, now here we have a formula. Now see in like chapter 6, wait a minute, chapter 5 when we did probability, remember we had like a table of PMF, right? Now here the this is actually PMF. So in fact I can write it here. Well, see the, I should have put X. This is PMF. Maybe I should have put like it is in a box. Yeah, let me put another one here. Should have it lowercase. PMF, okay, and then let me put another arrow here. Insert. Okay. Yeah, okay. So probability X, see the big X, this big X is used to describe the random variable. Little x means the specific value it takes. So little x is like numbers, 0, 1, 2, n. X is the description.
Like the
X,
patients or
yeah, X is a number of patients, number of smokers, like that. Okay, so that is the distinction between big X and little x. Okay, so now to find the probability that X is equal to a specific little x value. Now little x value can be 0, 1, 2, all the way up to n, and all should be integers, right? Now that is given by this formula. Now see, this again is called the binomial coefficient. I mean, we are going to talk about that in the next slide. And how you say that is n choose x. Let me write it down. So if you are to talk about this, you know, over the phone or something, you will say n choose x. N choose x is NCX, okay? Can I put an arrow from all the way here to there? Let's see. Maybe, maybe not. I cannot, right? Let me see. Then I'll copy that in here. Let me cut that. Okay, so it is n choose x. That's how you say it. Let me make it little n. Okay, so n choose x, and p is the probability of success. See, p is the probability of success. Q is 1 minus p. So if you think in terms of success and failure, p is the success rate, q is the failure rate. Okay, and then of course you have x and n minus x as the exponents. Okay, shall I go to the next slide? So you know, in the previous example, p was 0.75. That's like a 75% chance that the treatment will be successful. Q will be
failure,
which is 0.05. Okay, it's really not a big deal. Okay, now let me explain what n choose x is. Okay, that is called the binomial coefficient. Okay, here now. So how you, this is like notation again for n factorial divided by x factorial times n minus x factorial. Okay, now this means the factorial function. Have you guys, do you guys know this? You know, you can calculate this even, you know, using the calculator. Okay, and then 0 factorial by definition is 1. Okay, now in fact we can put another addition in here, n choose x. Let me see. I'll say n choose x. Okay, n choose x is the number of ways x items can be chosen out of n. I mean, this may not be needed for the, you know, for the to calculate, but you know, it is something you can keep in mind. Say for example, there are 10 people, 10 students here, and I want to choose 3 students randomly to form a committee or something. So how many ways can I choose? 10 out of 3, I mean 3 out of 10 means I can choose the first 3 of you or those 3 of you, like that. So there are several different bundles of 3. So how many bundles of 3 are there? It will be 10 choose 3. Okay, so that's how it is. Okay. All right then. So binomial coefficient. So you know how to find that.
Back 1 second, just 1 second. Go back.
Sure. So this is how you calculate this, okay? I mean, we will be doing problems. In fact, they call it the choose function. You know, that is fine too, okay? In fact, here it says the number of ways to choose x items out of n, okay? And then let's go here. Binomial calculations, okay? Now, so what is the probability of observing 0 successes? That means nobody got well, right? So, okay, let's see how that works. So, probability that x equals 0, right? So, this is actually p of, I mean, this is p within parenthesis 0, right?
Yes.
Right? Oops. Oh, this is lowercase p. Okay, that would be equal to 4 choose 0, 0.75 to the 0, correct? Times